Hello everyone, welcome to the first video for the AS Physics. The first topic that we will be discussing today is base quantities and units. Okay? So this will be the first topic for AS, base quantities and units. The first thing that we are going to discuss, you have already learned it in O levels. The basic quantities that we use, the base quantities, there are 7 of them. Mass, length, time, current, temperature, luminosity and amount of substance. Right? So this 7 quantities are called base quantities, and apart from that all other quantities are basically called derived quantities. Okay, so quantities other than this 7 quantities, all the other quantities are called derived quantities. Example of derived quantities can be many, like area. When we find area of a square, area is length into breadth, right? So square or rectangle, whatever you say. So here you are multiplying length twice. Even breadth is a length, right? Is a measurement of a length. So you are multiplying length twice to find a new quantity, which is area. When you are finding speed, what you're doing is you're dividing distance divided by time. So distance is basically a length and you're dividing it with time. So when you divide two quantities, two base quantities, distance and time, you get a new quantity which we call speed. When you multiply two base quantities, you get another quantity which we call area. Likewise, all other quantities are found either by multiplying them or by dividing them, not by adding or subtracting, either by multiplying them, dividing them, and we can build up new quantities. But these are the 7 base quantities, right? And the unit for each of them is masses, kg, meter, seconds, ampere, Kelvin, and moles. This is known to us, right? So these units are important. We will see in a bit why are the base units very important, because we have to see the derived quantities and the base quantities, how their units match up and everything. Okay. So let's go to the derived quantities and see their units. How do they write their units in base units? That's what we will see today, right? Okay, so let us start with derived quantities. Okay, so let's see what derived quantities can we deal with. So one of the derived quantities very commonly known to us is force. What's the unit of force? It's Newton, right? So this unit of force is the derived unit. Okay, just like we have derived quantities, we have derived units. It's not that all of them have the base units. So how do we calculate force acting on an object? The formula is mass times acceleration. Now, Newton is the derived unit of force. What is the base unit of force? So if you want to find the base unit of any quantity, what you do is you break down the formula with the base units. Like the mass has the unit of kg. Kg is a base unit, so that is correct. And acceleration is found using meters per second square, right? So meter is also a base unit, second is also a base unit. So the base unit for force is kg meters per second squared. That's the base unit for force. Likewise, we can have another base unit for energy or work done. Let's do this example. So energy, we know the derived unit is joules. So how do we find out energy or work done? Let's do it with work done. Work done is force multiplied by distance, right? Work done and energy will have the same base unit, right? So for force, the base unit we have already found is kg meters per second square. And for distance, you multiply another meter. So for work done or energy, the joule is written as kg meters square per second square, right? So this is how we break down the derived units into base units. Often you will have to show very complex quantities to show that they have the base units. Like one of the example that will be given to you is force equals to, maybe the equation is given G m1 m2 by r square. So if this equation is given to you and you are asked to find the base unit for force, how will you show that? Okay, so let's see that. Yeah. So as I was saying, so from here you will have to find out the base unit of force. From this one you will have to show what is the base unit of force. So we know the base unit of force is kg meters per second square, but if you have to show it, break it down from this equation, then how would you do it? Now some of the informations will be given to you. Okay, so let's say the unit of G. G here is a constant. We don't know what G represents, but the unit of G will be given to you in the question. So which is given Newton meter square per kg square. This is given in the question. Now you'll have to break it down, break the entire thing down, and find out what does the base unit of force come out as. So if you break it down, first you break down Newton. You cannot have it in the derived unit. So Newton is kg meters per second square. Then you have another meter square here, and then you have per kg square here, right? So what does it actually come out of? Kg, meter and meter square becomes meter cube, right? So instead of writing G, we just write down the unit of G, which is kg meter cube s to the power minus 2 and kg to the power minus 2, right? This is for G. And then you have m1, m2, which are two different masses. m1 is the mass of one object, m2 is the mass of other object. So when you multiply kg into kg, this becomes kilogram square, right? Kg into kg becomes kilogram square. And in the denominator you have r. R is the distance. R is given as the distance. This all will be mentioned in the question. So r is the distance, so you write it as meter square. Now you cancel them out. Meter square, meter cube. You are left with 1 meter. S to the power minus 2 will be there. This is kg square and kg to the power minus 2, right? So this is kg to the power minus 2, yeah. So this one and this one gets cancelled out. So what we are left with is this kg meters per second square. Kg meters per second square. So see, eventually the base unit of K of force is the same as you found it out here. So it doesn't matter which formula we use, however we go, eventually the base unit always comes out to be the same. Okay, so this kind of questions will be there in your exams. Maybe a bit more complicated formula, but doesn't matter which formula is given, you will always find it out that the base units always show up as the same. So this is how we find out the base unit from a derived unit. If you're given with a derived quantity, always break it down into simple formula, write down the units of those formula, of those quantities, and then break them into base. Like force, we wrote it here kg meters per second square, distance is written as meter, you multiply them and eventually find out the base unit for work done or energy. Okay. Alright, the next part that we are going to discuss is the homogeneity of an equation. Now, what do we understand by this term homogeneity of an equation? Now, an equation is said to be homogeneous if if you have the left hand side of the equation and the right hand side of the equation eventually give you the same base units. Like the left hand side of this equation is velocity, so meters per second. Now that's what the left hand side is. These are the base units. You cannot break down meters and seconds into further units because these are the base units. Now adding up the right hand side should also give you the same unit. Only then you can say the equation is homogeneous. So here u is also initial velocity. This also has meters per second. And when you break down acceleration, acceleration is meters per second square into time means into seconds. So eventually what you're left with is meters per second. This side is also meters per second. Meters per second square and second also makes meters per second. So you see this equation is said to be homogeneous, and the equation is correct because both sides of the equation have the same base units. All of them are meters per second. If you have an additional sign in between or a subtraction sign in between, that's okay, that's fine. Because when you add these two quantities, eventually the unit remains meters per second. If you add 5 meters per second plus 2 meters per second, the answer will be 7 meters per second. So it doesn't matter if you have an additional subtraction sign, but you have to make sure there is no multiplication or division sign because that will change the unit of it. Let's do another example. Let's say this one, s equals to ut plus half at squared. Now s here is displacement, u is velocity, t is time, which is in seconds, plus half doesn't have any unit, so we will ignore the number half. Acceleration is meter per second square, and t square is second square time, right? So this side, this per s to the power minus 1 and s gets cancelled out. So you have meter on the left hand side and you have meter here, and here you see s square or s to the power minus 2 again gets cancelled out, again you have meter. So you see that all the sides, both the sides of the equation, the left hand side and the right hand side, are homogeneous because you have all the equations in the same base units. So this is how we show whether an equation is homogeneous or not. Keep it in mind, if an equation is not homogeneous, if you see that the left hand side and the right hand side does not add up to the same unit, then we cannot say that the equation is valid. The equation becomes invalid because the quantities don't add up. They don't have the same base units on both sides. Okay, so that is why homogeneity of an equation is very important. We will come up with more examples like this when you solve the question paper, but this is how actually we solve it. So yeah, this is how homogeneity of an equation is solved. All right.